Hey everyone, welcome back to the channel. Today's problem is 1590 and the problem statement is make sum divisible by p. So in this problem we have given a array of integer nums and we have to remove smallest subarray such that sum of the remaining elements is divisible by p. We cannot remove the whole array and we have to return the length of the smallest array, and if we cannot do so, we have to return -1. So in order to solve the problem, first we will take sum of all the elements in the array. Consider this example. All the elements are 3 1 4 2, right? So the sum of it is 3 plus 1 is 10, right? And taking its modulus, we will get 4, taking its modulus with 6 with 4. And we can also note here is uh, taking modulus of 4 with 6 will we will get the same result. So we can consider that after taking modulus of total sum, we can consider 10 also, and we can consider 4 as total sum, right? So here, now what we want to find out is, suppose in the given example 4, we have to remove 4 so that the total sum of the remaining elements is divisible by 6, right? So for now, consider we want to remove 1 and 4 so that the sum of the array is divisible by 4. So how can we find the sum of these both elements? We can find sum of these element by taking sum of these elements and subtracting sum of this element, right? So what we can do is we can use prefix sum here. So what is prefix sum? Prefix sum is just prefix sum of 0 equal to n0, and prefix sum of 1 is equal to n0 plus n1, and so on. If we want to find the prefix sum of I, it will be sum from 0th element till sum of ith element, right? So discussed above, what we have to do is we have to remove these two elements from total sum in such a way that taking modulus with p, it will be 0, right? So putting this into a equation, suppose this is s and putting this into equation, we will get s prefix sum of minus prefix sum of j minus prefix sum of I, and taking modulus with p, we will get 0 here, right? And after further expanding this equation, we will get plus prefix sum of j minus prefix sum of plus prefix sum of I, and taking modulus of p, we will get 0. And then after expanding again, now what we have to find is, for the current index j, we want index I such that the after taking modulus with p, we will get 0, right? So taking uh, a prefix sum of I into left hand side and taking these both elements to the right hand side, we will get prefix sum of j minus s, and taking modulus with p. So for the current index j, we have to find an index I, which we have previously calculated, and if we have found this, we will simply take j minus I, which will be count of subarray, right? And we will save it in our save it in our answer, right? And this subtraction will can go negative also. So adding multiple of p does not affect our answer, so we can add 2p, 3p and p. So in this case, this will always be smaller than p, right? And adding with p, we can make sure that it will be greater than 0. Now to store the previously calculated i's, we can take here map of pi, taking map of pi, and here we will save integer I, right? So we will put this all into a code. Now we will begin our coding. Firstly we will take total sum, which is our s, equal to 0, and add all the element to it from nums, right? And as discussed above, taking modulus with p doesn't affect our answer, so we will take modulus of p here. And now was first we will check that if equal is equal to 0. In this case, all the subarray, sum of all the elements in the subarray can be divisible by p. In this case we have to simply return 0 here, right? Now we will create a map of integer map, new hash map. It will store our previously calculated prefix sums, right, and their indexes. So initially, for initial condition, we have to put 0 minus 1, right? And we will also create a variable to store our minimum count, which will be initially equal to length of our array. And now we will loop through from 0 index up to nums length plus plus. Now also we have to save a prefix sum in a variable, so we will create a variable here equal to 0. And now first statement will be, we have to um, increment our prefix sum with the current element, so it will be, and taking its modulus doesn't affect our answer, so we will take modulus before end. Now we have to find an pi in our previously calculated map. So if we found any pi, it means that the remaining sum will be 0. So we will take a variable here pi and subtract current prefix sum with s as described as discussed in our equation, and add a p here, so that our sum will always be greater than 0, and take modulus of it, right? Now we have to check if our pi contains in our map, right? If it exists, we have to update our min count. We will take minimum of math dot min, minimum of min count, and j minus I, right, as discussed in the here. J is our I, the current index, minus which we have stored previously. We will get it by map dot get and with pi, right? So this is our j, this is our this one index, and we will get this index by which we have previously stored. Now we have updated our min count, and here we have to save our we have to save the prefix sum index here, which is I, right? And lastly, as given in the question, if the min count uh, if the min count is equal to nums dot length, in this case we have to return -1, and else we have to return min count. Now run it. Let's run it for sample examples. Here, all right. As we can see, it is running fine. Now let's submit it and check if it is accepted or not. Yeah, it is accepted. So that's all for today. Thanks for watching.